Skill 14. We're doing some more trigonometry stuff. What we're introducing in this section is what we call the trigonometric functions. We're not going to get into the detail of what a function is. We'll sort of save that for an algebra course. You might do some other time. But regardless, to say these are going to be, maybe we'll think of them as three particular formulas that have to do with our right triangles. And they're relating the angles and the sides. We have the special triangles that we did in skill 13. So that was the 45, 45, 90 and the 30, 60, 90. Those gave us special relationships, right, for those particular triangles that helped us find different side lengths when we sort of had those particular angles. So what we're going to do here is try to generalize a little bit. Obviously, we're going to see other triangles just out in the world, in our lives, that aren't just 30, 60, 90s or 45, 45, 90s. So some sort of other tool to help us deal with those is going to be necessary. What we're going to use, just a little notation stuff here, right? What we're going to use for the angle, our sort of go-to variable is going to be the Greek letter theta. You can kind of see that here in the text, and it looks kind of like a zero, right? It sort of is a zero with the line kind of going through it. It's just a Greek letter. It's from the Greek alphabet. And so that's going to be kind of our go-to angle value. And the other piece of setup and notation we're going to use is we're going to be labeling each of the three sides in a triangle, and it's based on where this sort of perspective angle is. So the idea is that in a right triangle, you obviously have, in this case, right, the right angle, right, the sort of square angle. That one's going to be necessary, right? You sort of need that by definition to have a right triangle. And then you have kind of two other angles, the sort of corner angles. And so you're going to pick one of those to be what we think of as like a perspective angle. And that's going to be your theta. So you're sort of looking at this triangle from that perspective. And so from that, sort of standing in that corner, what we're going to do is label the three sides. So we have the easiest one to pick out is the long side, which is the hypotenuse. So that's the side that's across from the 90-degree angle, right? You have your sort of square angle here in the corner. Across from that, your longest side is going to be called the hypotenuse. That one's the easiest to pick out because it's always in that same position. There's not really any kind of ambiguity there about which side it's going to be. It's always the long side. It's always across from the 90-degree angle, right? We kind of said that the sides get longer as the angles across from it get bigger. So because you can't have, if you have a right triangle with a 90-degree angle, you can't have any other angles that are bigger than 90 degrees or else you'll sort of break 180. So the other two angles will be smaller than that, and so the side lengths will be smaller than that too. We saw this in the Pythagorean theorem, right? We had to identify the long side. Our a squared plus b squared is c squared. The c value was always the long side, and then the a and b values were the other two. We sort of referred to them as the legs. So what's new here, in some sense, is identifying the legs and being a little bit more particular about which is which. So we have two different names. One of them is going to be the opposite, and one of them is going to be the adjacent. So the two legs are going to be the opposite and the adjacent, and the positioning there depends on where our angle theta is. So the way that I think about it, and I think the easiest way to sort of remember this is start at the angle, and if you're, again, imagining yourself just sort of standing in that corner, looking out across the triangle, what you're looking out at is what we're going to call the opposite side, right? So the side that's across from theta, from your perspective angle, is going to be what we call the opposite side. If you then sort of turn, right next to you in that position is going to be the adjacent side, right? So opposite usually means sort of across. Adjacent really means more like right next door, right beside you. So the adjacent side is next to you. The opposite side is across from you. So from this perspective angle theta, the third side, of course, is always the hypotenuse. That also is sort of across from you, but because it's the long side, right, you're kind of identifying that first, and you're going from there. Now, what makes this a little bit tricky is, in theory, what's happening here is you could take this sort of same triangle And if you switch the position of your perspective angle, right? So rather than having it sort of down here in the bottom left, if I shift the theta, the perspective angle, up here to the top right, I'm not going to use the 90-degree angle. It's either going to be one of the two smaller ones. But if I shift it up here, now what's happening, right, is the side that's opposite, the side that's across from the angle, is sort of down here on the bottom. The side that's the adjacent side, the one that's next door, is here on the right. So the opposite and the adjacent can kind of switch roles depending on which sort of corner of the triangle you're referencing, which of these angles is your perspective angle, where you're sort of putting theta. So there's a visual aspect here, right? There's things that will sort of change a little bit depending on how you're marking it. So you always have to be very particular about that. You have to be very careful how you sort of do those setups. If we jump over to the homework section, the first couple questions here are really just about identifying the opposite and the adjacent and the hypotenuse. So there's different triangles here. You guys are going to be doing the odds for the homework in this section. So I picked one of the evens. So if this, right, question 2 is my triangle, I've got this sort of 90-degree angle down here in the corner. So I've labeled it, right? The side that's across from that is the hypotenuse. It doesn't even really matter where my perspective angle is in that case. The hypotenuse is always going to be that long side. The perspective angle is here in the corner. So then the side that's across from that, right, will be the opposite. And then the side that's next to it, that's sort of touching that angle, will be the adjacent. So I've got the hypotenuse up here, the long side. The opposite is here across from the angle, and then the adjacent is next door. So that's kind of setting up, right, the opposite, the adjacent, and the hypotenuse. That's just a labeling piece, however. So if we come back here, what we're going to be doing is defining these 3 trigonometry functions, the 3 trigonometric functions. And so the 3 that we're going to be using are called sine, cosine, and tangent. So you can sort of see it here in the book, right? Sine is S-I-N-E. It's abbreviated as just S-I-N. Don't say sin, right? It's sine. I know it looks like sin, but you're going to say sine. Cosine, right, sort of goes with it. COS is the abbreviation there, COS. And then tangent, the abbreviation is TAN. So sine, cosine, and tangent, you'll see them just as the abbreviated versions on a calculator or pretty much any time we're using them. We're not going to sort of write out the full word. And the definitions here, what we're going to be doing is we're defining these values. What they are is essentially sort of ratios of the different side lengths in a particular triangle. So it's going to be relative to that perspective angle, right? So the idea is if I have a sine of the angle, so I'm looking at this angle and I'm trying to find what is the sine value. So what it means is it's a ratio, and it's the opposite side length divided by the hypotenuse. So sine would be opposite over hypotenuse. If you know the angle value, that's great. But in theory, you don't even need to know the measurement of the angle. It really is a relationship between the side lengths more than it is an actual relationship between the angles. Cosine is going to be the adjacent side divided by the hypotenuse. So cosine is the adjacent over the hypotenuse. And then tangent is going to be the opposite side divided by the adjacent. So we have these sort of 3 different ratios, right? This sort of are 3 different sides. And if we're sort of pairing them up, these are the 3 possible pairs. In theory, there are other, we're not going to use them here, but there are 3 other sort of reversed versions, flipped versions of these formulas. They would be what we call the reciprocal functions, right? Or reciprocal, where you're taking those and flipping them upside down. We're not really going to be using those for the most part. Anything we're going to do, you can sort of just use sine, cosine, and tangent. So that's what we're going to focus on, the big 3 there. Sometimes what people say, a little mnemonic to help you remember, is SOHCAHTOA. So that's SOHCAHTOA. SOHCAHTOA. You get a little bit of a Boston accent thing kind of going in here. TOA. If you want, you certainly don't need to. In any event, SOH, sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And TOA, right, tangent is the opposite over the adjacent. So it's just a quick little mnemonic to sort of help you remember how to go between all these different values. And it's there. So what we're going to do is just run an example first. If we sort of check the book, their first example in this section, right, is if we know all of the different side lengths in a given triangle. So in this case, I've got a triangle here that sort of is a 12, a 9, and a 15. I don't actually know the value of the angle. I'm just using my theta as a stand-in for the perspective. But those are the different lengths. And so first we get to do a quick little identification thing, right? So which is the opposite, which is the adjacent, which is the hypotenuse. The markings are here. I'll sort of mark them here as well, right? My hypotenuse there is the 15. My angle here, right? My theta is here. So 9 is going to be opposite that, which then means 12 is the adjacent. Apologies for the camera work there. I don't have enough hands. So once you have that, I usually identify them in that order, the hypotenuse and then the opposite and then the adjacent. Once we do that, you can sort of see the setups here, right? So you're saying the sine of that particular angle, the sine of theta, is going to be the sort of ratio of the opposite side over the hypotenuse. And so this is honestly just a pretty boring fraction, right? You're just saying, well, the lengths here are 9 and 15. So if I divide them, I would get a 0.6, right? You can sort of have the fraction and then divide it down into some decimal number. Similarly for cosine and tangent, right? So cosine is the adjacent over the hypotenuse. So you're just looking at those side lengths, right? The adjacent is here is 12, the hypotenuse is here is 15. So adjacent over hypotenuse, 12 over 15 would be 0.8. Tangent, opposite over adjacent, so that's going to be 9 over 12 would be 0.75. Right? So we can kind of run this stuff and sort of get these values pretty quick, provided we know all the different side lengths. If we pick another one just from the homework, just to have another example here. So say number 6, right? So I've got this triangle, 12.7, 8.6, and 9.3. I've got it set up over here. I've labeled the different side lengths, right? So my angle is up in the top left. So my hypotenuse is the 12.7, the long side. 9.3 is my opposite. That's across from it. 8.6 is my adjacent. So then I'm just setting up, right? So TOA, sine is opposite over hypotenuse. So setting that fraction up, 9.3 over the 12.7. If I divide it, I'll get a 0.73. Cosine would be the adjacent over the hypotenuse, right? So the 8.6 and then the 12.7. Divide it, 0.68. Tangent would be the opposite over the adjacent, the two legs, right? But in that particular order. In this case, 9.3 over 8.6. It looks like that's going to be 1.08. So finding these values, we can do it relatively quickly as long as we know all the different side lengths. So we'll keep going with this kind of thing in the next video.